Hello, everyone. Welcome. So analyst research shows that about 65 of enterprise applications are now considered legacy. And when we say legacy, we typically mean applications that rely on outdated technology. They are hard to maintain, they are hard to extend. Furthermore, they typically use about the majority of the IT budgets, which of course is expensive. So it is imperative for CIOs to modernize those legacy applications to improve the agility and improve the efficiency. Now, traditional modernization usually meant long and very manual projects. But with the advent of generative AI, things are changing quickly. AI agents can do reasoning, they can use tools, they can do multi-step workflows, and all of this can dramatically increase the speed and the quality for executing modernization tasks. And so that's what we want to talk about today. We want to show you AI-based reusable patterns, and we want to show you real AI agents that are already working for customers. And to do this, I'm very pleased to co-present with Matt Lewis. Matt is an AWS chief architect with IBM Consulting. He's also an AWS hero, AWS ambassador, and he works with enterprise customers to build AI-based innovation. My name is Phil DeValence. I'm a principal product manager with AWS, and I focus on building AI agents with AWS Transform. So let's go together through the agenda for today. So we want to start with describing the approach for modernizing legacy applications. Then we'll show you some patterns and how AI agents can help. And then we're very excited. We've packaged 7 demonstrations for you to really show this all in action. We'll show you modernization activities using AI from reverse engineering to forward engineering. So let's jump right in, and I'll hand over to you, Matt.
Thank you. So we're going to start at a high level looking at the approach for modernizing legacy applications. So organizations today tend not to have just a single monolithic application, but quite a disparate IT estate. It can be made of a diverse set of systems, technologies, languages, frameworks. And with this, it brings a whole range of challenges with them, from things like undocumented code and technical debt. And it's these challenges that are driving the real need to try and modernize legacy applications. And these reasons to modernize tend to fall into 4 areas, but they're not mutually exclusive. A lot of the time, we find that most organizations are looking to achieve all 4 of these things. So it covers areas like moving away from expensive proprietary software licenses, going from CapEx to OpEx and trying to drive cost savings. It can be embracing a DevOps approach, where you're looking to try and deliver small, frequent, iterative changes to become more agile. It can be taking advantage of the latest features that are available in new releases and provide opportunities for innovation. And can also be utilizing features as you move to cloud of things like auto-scaling, multi-AZ, multi-region, to try and provide greater resilience. And we see there are 2 approaches, and these can be complementary as well. They contain a set of tasks or activities within each. So the first is reverse engineering, which is all about breaking down an existing system to try and understand how it works. So analyzing that system to understand its features and components, potentially updating, creating new technical documentation, extracting the business rules and the business logic, decomposing that system down into discrete modular components, and then looking at how you can plan to migrate those. Forward engineering is all about starting with that set of requirements, then looking at how you can build a new system, potentially in a more cloud-native way. So that involves looking at how you can transform the application, looking at building out new deployment pipelines into the various different environments, looking at how you can create APIs to integrate into internal systems, all the various different test phases, and then finally planning for the cutover, as it's only when you decommission the existing application you can start driving those cost savings.
Thank you, Matt. So now we're going to go over modernization patterns and how AI can help. So let's start with how you typically modernize the application stack. So modernizing the application stack is really important to be able to remove the outdated technology. And there are various ways to doing so. So you can see on the left-hand side a typical legacy application stack, right? Everything that you see in blue is what's not changing, and what's in yellow is what is actually changing throughout the various patterns. So when you start looking at rehost, essentially you're taking the application stack from the operating system up You're not changing it, and you're doing a lift and shift onto a modernized compute. And that already gives you some agility gains, especially like starting introducing cloud-based practices. When you move toward the right and you start looking at replatforming, then that's where you're changing more of the application stack. You're changing the runtime, you're changing the database type, for example, and you can get even more operational efficiencies. You can start leveraging managed services, for example. Moving to the right, you have the refactor pattern, where you actually start changing the complete application stack, including the language, including the framework, so you can get rid of much more of the outdated technology that you may have within that application stack. But what's very important here is that the business functions are staying the same, which means that you can leverage a lot of tools and automation to do those transformations with speed and at scale. If you move further to the right, then you start changing the business functions as well. Let's assume you have an application that still needs to evolve, right? Business needs are evolving. Then you can further refine those business functions, which also means that you're going to have more ad hoc tasks that you need to perform while doing that modernization, and less automation that's available to you for doing those transformations. Now, when you have a large application portfolio, there is no one-size-fits-all, right? So you will have to decide application by application which modernization patterns is best suitable for your specific situation. Now, beyond modernizing the application stack, the other way to really modernize the application is by doing decomposition. And decomposition is really geared towards moving from tight coupling to loose coupling so that you can have more agility, more flexibility, possibly more scalability as well. And there are two dimensions for the decomposition. You have the technical decomposition on one side, and then the business decomposition on the other side. So let's start with the first one, technical decomposition. So I'm showing you here on this diagram the various types of applications, from starting from the left, when you have a large mainframe application portfolio where everything is bundled, moving to the right, looking at the distributed application monolith, then to the right, modular monolith, up to creating microservices. And when you move from mainframe to distributed type of application, you can already see that that technical decomposition is already done, right? Essentially, you're separating the application into layers so that for each of the layers, you can optimize the framework, optimize the language, and have better efficiencies. Typically, you would separate the presentation layer from the business logic layer from the data layer. Now, on the business decomposition side, you're going to make some further decomposition so that you can better align your application with the business needs, so that you can have more granular teams that do not have the tight coupling with and other dependencies on other development teams, so that you can go much faster in terms of deployment and in terms of introducing new business functions within your application. So with the business decomposition, you really improve the deployment speed and the agility for modifying applications. Far to the right, you can see the microservices, right? And microservices have a lot of qualities. They allow you to have tech choices, you have better scalability, you have better time to market, you can have like a very granular choice in terms of tech stack for each of the microservices. But at the same time, they increase the complexity. You have more latency, you have to deal with distributed transactions, you may lose the ACID property of your transactions, you have to deal possibly with eventual consistency. So it's not a one-size-fits-all again. You have to choose what's most appropriate for your application and your own organization. And it could be that a modular monolith could fit the needs. All right, now for doing application stack modernization or decomposition, you have to think about how you're going to transition from the older application monolith to the newer stack, to the modernized application. And one popular pattern is use the triangular pattern. Essentially, it allows you to incrementally extract functions and applications from a large legacy monolith into a modernized environment. Basically, you introduce a gateway, you introduce some integrations between the old and the new, and over time, you reroute the queries to the new environment in order to be able to do smooth transitions. Now, the new services could be microservices could be full applications, right? You decide what the proper granularity is. But it's really a good mechanism to be able to secure the transition, and if actually your modernization is not suitable, you can always revert back to the older application as well. So it's really a good mechanism to reduce the risk for doing incremental modernization. All right, this being said, let's see how Agentic AI can help for application modernization. So typically for modernization, you need tools, you need some expertise, you need a good methodology, good processes, and also some flexibility because you're always going to face some edge cases. Well, Agentic AI can really help with many of those dimensions. If you look at AI agents, they have key characteristics that are useful. They have a UI so that they can understand the goals, and they can do reasoning about decomposing how that goal should be achieved, and they can call other agents. They can observe the assets, right? For example, they can understand what the language is for a specific application. They can understand the framework. They can also have access to tools so that if there are specific operations that needs to be done on a legacy application, such as a conversion, that they can do so as well. They can have access to knowledge bases with best practices on how to do modernization. They can do feedback loops as well so that if the transformation is actually iterative, they can improve on the quality over time. So there are a lot of mechanisms in agentic AI that are very suitable for application modernization. So the way it would typically work, if you look at that diagram here, you would have a user that would talk with an orchestration layer, for example, an orchestration agent. The agent would understand the goal, decompose the goal into executable tasks, and then call the right agents to be able to achieve specific outcomes. That's a simplistic example where you can see one analysis agent, one transformation agent, one test agent. But the idea is that each of the agents would be able to observe the input, execute some parts of the modernization activities, and then provide some outcomes. And the way we would do it at scale is that for a legacy application, we would put all the application artifacts, for example, in a repository, have the agent have access to that repository, and over time modernize each of the artifacts so that the full application can be modernized at scale. So all this really helps to reduce the modernization timelines. So here I want to showcase some of the capabilities that AWS provides for application modernization that are agentic. First, I'm going to start with AWS Transform. AWS Transform is an agentic AI service for large-scale modernization. It has expert agents that can do mainframe modernization to the cloud. It can do .NET modernization as well. It can do VMware to EC2 modernization. And we've just introduced on Monday also custom transformation through AWS Transform. QDeveloper is a coding assistant that resides within your IDE. And it can help with various tasks within the software development lifecycle. So it really meets you wherever you are in your IDE, which can be VS Code, which can be JetBrains IDEs, for example. And then on the right-hand side, you can see Kiro, which is the latest agentic IDE that AWS had released. And it's been optimized for agentic collaboration in order for you to be able to fully utilize the potentials of AI agents. And it has a strong focus on specification-driven development so that you can create production-ready applications. And now, we're going to move over to the demos.
Yeah, so for the first demo, we're going to look at how you can examine, analyze code, and try and create a specification from that. So one of the things that we found is that if you try and translate directly from one programming language to another, you often end up with this sort of semantic drift. And that's caused by differences in the various different idioms within programming languages. So you may be going from a sort of structured language to an object-oriented or a functional language. So we end up having these little differences. We also typically find that many legacy applications have significant parts of code that have been developed to take into account a limitation of the underlying platform. And so when you look to move that across to a new platform, those limitations no longer exist, and you don't really want to bring all of that code as technical debt across with you. So the best practice that we have today is to try and ground that modernization in a design specification. So this is a demo that sort of shows at a high level one of those ways in which it can be automated, also using a human in the loop to help evaluate that. And this is going to be using step functions. So it's a GitHub repo which code's available for people to download and run. So on the screen now, there's the high-level architecture. It very much looks at sort of serverless data processing. So it starts with a legacy source code file being dropped into an S3 bucket. The bucket is configured to send event notifications to Amazon EventBridge. Then within EventBridge, we have an event selector within the EventBridge rule. So that is listening out for object-created events from that bucket. We can also use filters to select it down to particular file types. You can then also use things like input transformers, and you can start trying to map the actual payload structure. And then in the EventBridge rule, you can target one of a number of AWS services. In this case, we're targeting a state machine. Within that state machine, we have 4 tasks. The The first task goes and reads the contents of that file in. The second task then calls an LLM that's hosted on Bedrock to generate a specification. The third task then writes that out in a markdown file in the output S3 bucket. And then we create an SNS notification with a pre-signed URL. And that ends up in an email subscription. So we can have a business analyst that we may not want to provide credentials to access the AWS console or the AWS CLI, that they can literally click on a link, download the specification, and part of the human in the loop, they can then agree and state whether they're comfortable, and that is exactly what that part of the application does. So the way in which we generate the specification when we call out the large language model on Bedrock is using a prompt template. So this is a prompt that defines a set of instructions and guidance in terms of how the model should behave. It gives it its sort of persona, and you can start being explicit around the type of data and the structure of the response that you want to get back. In this prompt, we also include dynamic placeholders, which then that will get replaced at runtime with the content from the input file. And then we go and invoke the model in Bedrock, and this is using the Converse API. So it's a unified API that works for any model that supports messages. So this means that you can choose the most appropriate model, whether that's based on the specific task that you're trying to carry out. So you choose a model that supports the Converse API. You create the user message to send to the model. You create a command object with all that information, so the prompt, the model ID. You can also include parameters for inference, so you can tune attributes like temperature to control how creative the output is, and things like the maximum output, so the number of tokens that can be returned. And then we send the command to the model. So in this, as a very simple demonstration, we take a source file that's written in Rex, which is a scripting mainframe language. So again, it's just an example of a language that a lot of people won't understand or be familiar with. And what we can do is we can go and upload that to an S3 bucket. That triggers a state machine. We click on that, we see it's running, and here you see the visual editor within step functions. That goes through the task completed. So now we can go across and check the email. So we could be a business analyst here. We get the email saying a new specification has been created. They can click on the link and download it. And then when we go and open that up, we can see now that we've converted that raw source code file into a specification.
Nice. So now we're going to move to another demo that's about understanding the code and extracting the business logic. And as part of modernizing any legacy application, well, it's critical to really have a good understanding of the legacy application. And oftentimes, because it's been so old, well, it is very hard to find the people that actually have a correct understanding. And even if they have an understanding of that application, there are little details that are hard to grasp. So the goal of this demonstration here is to show you with AWS Transform how we're going to understand the code and extract the business logic. All right, so imagine you're an application analyst and you're tasked with providing a detailed description of what's happening in a legacy application. And we're going to use AWS Transform for that purpose. So essentially with AWS Transform, as a user, you provide a goal. AWS Transform will understand that goal, will identify the agents that are necessary to execute on that goal. So in that specific demo and example, we're going to go through one analysis agent that's going to extract raw analysis data. Then we're going to move to another agent that's capable of doing the business logic extraction. Then another agent that's able to generate the technical documentation for that legacy application. And finally, a chat agent. And the reason why we have a chat agent here is because when you start extracting information, that information can be overwhelming, right? You could have hundreds of pages of documentation, and it's very hard to find exactly the information that's pertinent to what you're trying to achieve. So the idea with AWS Transform here is that not only we're able to generate that information, whether that's technical, whether that's business related, but we also provide the ability for the user to access that information with natural language queries, right? Through the chat, you're able to ask specific questions so that you don't have to go through the entirety of the documentation and find the answers that you're looking for. So let's see it in action. All right, so this is a AWS Transform interface. I asked for a mainframeization job because that's a mainframe legacy application. I asked for creating the technical documentation and business logic extraction. First thing I have to do is specify where my application resides. It's a zip file within an S3 bucket at this time. And then it starts analyzing the code. By the way, we removed all the wait time, right? So you're only seeing the active actions here. Once the analysis is done, you'll be able to see analysis information. So you can see, for example, the application breakdown. It can tell you if there is anything that's missing, anything that's actually outstanding. Then you get into business logic extraction. And within the business logic extraction, you get various layers of business logic information. You can get information at the application level, but also information at the functional group level, then at the component level. And so that's what we're going to show you here. Right? At the overall application level, you get a summary, and then you get a good description of all the functional groups that are part of that application. And then you can start drilling down to get more specific information. You can get to the component level, and again, get a business summary of what that component is about, and then you can continue drilling down. And you can start seeing here that you also have workflows of what the business logic is actually doing within that application. And if I want to get the maximum level of detail, I can even go to the program level, where I'll see every single action and business function that is contained within that program. You'll get some statistics about how much quantity of business information and business functions is present, and you also get what's very valuable. You get a complete workflow with all the decision points, all the branches that you have in the code, and all the logic that resides in the code with all the input and output data stores. And finally, you have a full list of all the business rules that are present within your application, so that when you're doing monetization, you can make sure that that monetization is comprehensive and you're not missing any of the business function. All right. So after the business logic extraction, we're then going to move to the technical documentation generation. So this is a different perspective on how the application is being structured, because depending on the pattern that you're choosing, sometimes you need some technical related information, sometimes you need some business related information, so they complement one another. So when you get into the technical documentation extraction, you have to select exactly which pieces of your application you want to document. Then you can actually see the specific, for example, for one program, and that's what we're going to do here. We get into one program, you have that PDF that contains a lot of the technical information about that application, that program. So you'll be able to see all things around integration, right? Specific integration from two programs, between two programs or with an external system. You'll be able to see all the inputs, the outputs. You'll be able to see error handling as well, right? So there's a lot of technical information that's present and available to you, so that if you need to know more about what the application is doing, that's readily available. And finally, what you're observing here is the chat experience that you have once all that information is generated, right? You can ask very specific questions. For example, for this specific program, please tell me which data set is being used, right? And it's very hard, it can be very time consuming to find that information. You may have to find which document has that information, it may be difficult. While through the chat interface, it actually does the work for you, right? So that you can be very focused on achieving your tasks and really focus only on the information that's pertinent to you. All right, what I wanted to show you as well is that not only we provide PDFs, but you also have the UI from AWS Transform to provide the information. What's important is that we also make that information available in a JSON format. And the reason we're doing that is because we understand that when you do application monetization, it can be a very complex workflow. It doesn't necessarily all happen within AWS Transform. You could have your own mechanisms that you want to use. So we want to make sure that this information is reusable. And because it's in JSON format, then you can reuse it for other purposes. You can use it to create specification, like Matt was showing. You can use it for creating test cases. It can be used for lots of other purposes as part of your monetization workflow. So this was about extracting technical documentation and business logic. Over to you, Matt.
Yeah, and now we're going to look at a demo that looks at how you can upgrade runtime and dependencies. So this is based off a bicycle license application. This was written around 5 years ago for an AWS webinar, and effectively it's just been sat there on GitHub now, slowly degrading over time. So then when we look at it, we know it's running a couple of libraries in terms of it's using Java 11 as the runtime. It's got Spring Boot, it's got the AWS SDK, and these are all now significantly out of date. We want to be able to port that across towards a supported version. So originally, this is one of the original slides. This was just going into QDeveloper, into the chat, and basically asking it to look at the code base. So we've cloned the repository down to my workstation. We sort of ask it if there are any libraries and frameworks that are out of date, and it comes back and says, well, actually, there's two that are critical in terms of Java and Spring Boot, and there's one that's a high priority. So we know these are the three that we want to try and upgrade. And then, as of earlier this week, AWS Transform released AWS Transform Custom as a new capability as part of the AWS Transform family. So what I've done here is I've cloned that repository to my local file system. I've installed the AWS Transform CLI, so I can then go and run ATX, which is the AWS Transform CLI command. And it opens up the CLI in my terminal window. And here I just enter a simple natural language prompt saying, upgrade my Java application. The first thing that the CLI does is look through its set of pre-built AWS managed transformations. So there are 8 of them that have come on sort of day one, and then you can go away and you can create your own custom definitions for a transformation. And one of the things we find down here, number 7, there's one around Java version upgrade. So the CLI comes back and says, oh, I've identified there is one to upgrade the version of Java, so that's what I'll use. The thing that's nice about it as part of this sort of agent as it runs along is it sort of gives me the opportunity to say, is there any more information you want to provide as part of that? And within that, I sort of say, well, don't just upgrade, against the natural language prompt, but don't just upgrade the version of Java. I also want you to upgrade the version of the AWS SDK from V1 to V2 for Java, and the version of Spring Boot. And then this all gets passed off to a separate planning agent, so a specialized sub-agent within the Transform CLI. This goes away and creates a plan, and the plan is a JSON array. It's a plan.json file that gets created that you can open up, you can look through. So you can see within this array, it breaks down the plan into a series of steps. It provides things like the commands that we run to verify that. And it asks you for input, whether you're happy with that plan and you want it to go away. And if you are happy, it'll go away and it'll hand it off then to another specialized agent, sub-agent, which is the execution agent. And as the execution agent goes through, it goes through each step one at a time. And you can actually see interactively in the console that as it's going through, it may detect things like compilation errors. So in this case, it's detected a compilation error because the more recent version of Spring Boot within one of the Spring libraries has a new interface method, which is a breaking change. So as it goes through, it detects that compilation error, and it goes and adds the new interface method in. So it fixes it. And one of the things that I found at the end of the execution was that it comes back and tells me, it runs a verification step, and it tells me the transformation is completed successfully. So now the application is running on each of the long-term supported versions of Java, Spring Boot, the AWS SDK. And each of the phases, so it says there's 4 phases being successfully completed. Each of those 4 phases has been carried out by a specialized sub-agent within Transform. So this is when you start looking at multi-agent systems. And what I found was that as it carried out each step, because it requires a Git initialized repository to work in, as it carries out each step within the plan, at the end of each step, it goes and creates at the beginning, it creates a new branch, and at the end of each step, it creates a new commit. So then when I push that up to GitHub, I can go and see that there's a new branch there, and I can see all of the different commits in there that I can go and look in, and I can go and then raise a pull request and merge that in if I so desire, and then I can go and carry out doing integration testing. So at the end of that, after running the Transform CLI, I can literally just go and run the script to start up the server, and you can see that it was running on the latest version of Spring Boot. And Java, I can then go in and I can go and create, this is a fictional bicycle license I can go in and create. I can go and add myself some fictional points in my fictional license. And then when I go back to the history, and this is all stored in DynamoDB, I can go and look at the events and see that's all been created. So we've ended up very simply using the AWS Transform Custom, using the new CLI, being able to upgrade both the version of Java, Spring Boot, and move that onto a supported version.
Nice. Thanks. So now we're going to move forward towards forward engineering, and more specifically around how we can do replatforming for cross-platform portability. So what happens often with legacy applications is that they're tied to specific runtimes or tied to specific versions that are kind of locking you in onto specific platforms. And in order to meet the latest IT standards or to have more flexibilities, and you want to be able to move those applications towards more possibly cost-efficient or flexible platforms. And so portability is really important to make sure that you can choose the best suited platform for your application. And what we're going to show in this demo is replatforming of a .NET application. Essentially, we're going to move from a legacy .NET version 3 application that's tied to Windows. It only supports Windows. And we're going to upgrade it to a modern .NET version 8 so that this application can then run cross-platform, and more specifically on Linux here. So the way it works is that we're going to use AWS Transform again. With AWS Transform, we're going to feed it the application code. AWS Transform is going to start going through some analysis. Based on that analysis, it's going to propose a transformation plan. That transformation plan actually is flexible. You can adjust it if need be. And then once you agree with the transformation plan, then it's actually going to go on executing that transformation plan and upgrading the various packages, making sure everything is compatible with .NET version 8. And it's going to do all this until it's done and shows you a summary of the complete transformation with lots of details about what happened. Based on this, you'll be able to take some actions, right? You can validate all the changes, but if there are some next steps as well, it's going to provide detailed list of what needs to happen in order to successfully complete your modernization. One important aspect of the transformation is that as part of the process, it's also doing some builds to validate that the changes are actually functional and operational. And so if the build is not successful, it's either going to try to retry a different mechanism, or it's going to provide you with the outcome of that build error. So let's see it in action. All right, so that's a .NET version 3 application, which is loaded into Visual Studio. That Visual Studio, through the AWS toolkit, is actually connected to AWS Transform so that it can submit a job to AWS Transform. So we're going to start by asking AWS Transform to port a project from .NET version 3 to version 8, which you're seeing here, and then start the analysis, as I said before. So it's going through all the packages of the .NET application to identify everything that needs to be done, and then provides you with a detailed plan, right? Everything that's it's going to do is actually explain in that document so that you can tailor it to the specific needs. If you think there is something that's not appropriate, you can definitely remove it. Then we submit the plan for action, and the transformation is ongoing. Now you can see it's going through all the steps of the transformation plan with very detailed logging so that you're fully aware and fully transparent about what's happening under the cover. And then it's going to show you the transformation report, where you can see all sorts of details. You can see the summary of what has happened. You can see some statistics about what was completely upgraded, what was partially transformed. You can see about the project itself, about the various packages. It's going to show you as well the build errors so that you can take some action from there. It's going to show you for each of the file how it's been changed, so that you can do evaluate the differences and see the impact and whether you want to accept this or not. And then finally, it's going to show you the build errors here. It's going to also show you the Linux readiness, right? So if there are things that are still deemed not complete in order to be fully Linux compliant, then it's going to also show you that level of detail. And what's nice is that beyond this documentation, it's also preparing for you a markdown that has all the suggested next steps, so that either you can do those next steps manually, or you can use the help of an Agentic IDE and an LLM to actually help you on executing those next steps, right? So it provides you a lot of flexibility for achieving the next step actions. And finally, once you're happy with all the transformation, you have the ability to review all the differences, accept the changes, and once you accept the changes, then you have your application that's running with .NET version 8. So you've been able, through that demonstration, to successfully modernize to version 8, which is now cross-platform portable, and which means it can also be deployed onto a Linux platform.
Okay, so now we're going to look at how we can generate code from a specification, but more importantly for a lot of organizations today, how we can generate that code that conforms to some of our corporate standards. So hopefully many in this room are aware of Kiro. It's been a hot topic this week. So it's the new Agentic IDE from AWS. It's very much built around spec-driven development. And starting from a specification has a number of big benefits. So one, it sort of provides a way that both the business and technical stakeholders can agree on the goal of what the solution should do, but it also provides a guide for AI agents to work from. And for those that went to Werner's keynote, his closing keynote, you've seen a big slide on screen that basically states how specifications reduce ambiguity. So in this case, we create a prompt that sets out what it is that we want to build, but we're giving no other guidance to Kiro. So we're saying that we want to create an API. It's a very simple API, but it's going to be a sort of like a serverless-focused one, API gateway, Lambda. We want it to be written in Node, and we want to configure it using the AWS serverless application model. So Kiro goes and takes that natural language prompt using spec-driven development, and it breaks that down into a requirements document, so a requirements markdown file. And this is one you can interact with and you can suggest changes and updates to. So it uses something called EARS notation, which stands for Easy Approach to Requirements. And they're sort of event-driven requirements. So within each requirement, you'll see the acceptance criteria, and that starts off with a when, which is the trigger. So when a client sends a post request, then you've got then, which is the system name or the component that should react to it, and then the trigger, which is the shall, is the response that happens. So when a client sends a post request with two valid numbers, then the multiplication API shall return the product of those numbers. So once you're happy with those requirements, you can go let Kiro go and generate a design document that takes into account those requirements. So it sets out an overview, it creates a little architecture diagram. It also creates something called correctness properties, as of about a week or two ago. So a correctness property is something that defines a universal statement that holds true in a given circumstance. So it takes those properties and it creates property-based tests using a framework called Hypothesis. So if you're happy with the design document, you can go and accept it, and then Kiro will go and create an implementation plan. And this breaks it down to a set of tasks, and these tasks, you can see the mapping from the task to the individual requirement to make sure that all of the requirements have been satisfied. So on here, you'd click the start task, and then Kiro, using an agent, would go and start generating the code for that. You'd then go and approve it, and once you're happy, it would then move on and start the next task. So this is what we did using the original prompt. But what we found is that when it generated, for example, the SAM template, it had targeted an out-of-date version of the Node runtime. There's also no things like tracing, which we wanted to have across the API. And then we looked at things like the Lambda function that gets created. We see things like no structured logging. There may be specific libraries, like the Lambda power tools we wanted to use. We may want to create some CloudWatch metrics. We may want to do more tracing. And this is where, within Kiro, there are capabilities that you can provide that can help it conform to your corporate standards. And this is through things like steering files, MCP, and RAG. So we start off with steering files, and these are markdown files that you provide that could be at a global level or an individual workspace level, and it gives the persistent knowledge to Kiro. So within here, we've created a markdown file which is around serverless API standards, and we explicitly call out that when you're looking to do something with AWS SAM, call out to this MCP, and we reference the MCP that has been configured. So for the MCP setup in Kiro, it follows probably using an MCP JSON file, which is probably now becoming more of a sort of de facto standard in terms of how you provide MCP capability to coding assistants and agents. So we define two MCPs here, one for Lambda Power Tools and one that actually maps to a knowledge base on Bedrock. So what we've done then is we've taken a whole set of markdown files where we've specified snippets of code showing what we believe is best practice, our company standards. If you want to do logging or exception handling, this is how you should set up your code, and this is how you create it. And we put those markdown files into an S3 bucket, and we've created a knowledge base using something called S3 vectors. So this is something that went into GA this week at reInvent, and it basically provides a very low-cost, scalable option of providing a vector store. So with that, what happens is when you create a knowledge base using S3 vectors, Bedrock will end up ingesting those markdown files. It will chunk it up. It will create the vector embeddings, and it will store them with a vector index in a new bucket type called S3 vectors. And then you can interact with that through Bedrock, and it will pull back the relevant chunks of text. So now what we do is we go back into Kiro in the new project, and we enter exactly the same prompt as we entered originally, asking it to go and create this API, and we wanted to use these AWS services like API Gateway and Lambda. We wanted to use SAM. We want to write it in Node. And you can see straight away that Kiro is now, well, I'm including these steering documents. So this then helps provide it with that persistent knowledge. Then when we accept it, it goes to create the design. It starts by reaching out and calling out to those MCP tools. And you can even see where it's gone and pulled back the chunks from the vector store. So it pulls back the relevant information. And at the end of the design, it even tells us the information that the design now incorporates the AWS standards from your knowledge base. So it's going to be a Node 22 runtime. It's using MIDI for middleware. It's using the AWS Power Tools for logging, tracing, metrics. And we can see then that in the SAM template that gets created, it is now using Node 22. It does have tracing enabled. And then when we go and look at the Lambda function, we can see it has all of the libraries that are imported that we wanted to import. It's gone and created a structured logging output. It's gone and created its own CloudWatch metric. So it has followed exactly how we want our corporate standards to be. And then moving on from here, looking at putting some of this together in a more automated fashion, this brings us to building agents using Strands. So Strands Agents is an open source SDK. It's released by AWS, and it provides a simple code-first approach or code-first framework to building agents using just a few lines of code. So what we do here, again, we're following this multi-agent approach using something called an agent as tools pattern. And that is where we use one agent as an orchestrator agent, and that orchestrator agent then manages across a series of sub-agents, and it can use its own reasoning capability to know when it needs to call something. So we have 4 tools that we're going to provide access to. 3 of them are agents, so like a design specification agent, so we can go and generate a design specification from an existing piece of code. An implement from design agent, so an agent that's trained to go and generate, in this case, Python code from a design specification. A Python code improvement agent, so if there's any compilation errors, we run into issues with Python, then we can throw it to this agent. That agent knows how to fix those errors. And then finally, a Python compilation tool. So this is using something called Code Interpreter. So it's a containerized environment within Agent Core on Bedrock. So that provides a secure, isolated execution environment in which we can run, AI agents can run and execute code in a safe way. So this is how we set up the orchestrator agent. So we use the Bedrock model provider. So the model provider is how you link up the agent to the LLM that it can use its capability. So we use the Bedrock model provider, and that then allows us to use a model ID that's hosted on Bedrock. But because it's an open source SDK, there are other model providers that are available. So it provides a provider for things like OpenAI, for Google Gemini, for Llama, for Mistral, for Anthropic. There's also, you can provide your own custom model provider. So you can target this against internal LLM services you may host to keep everything more private. We define the system prompt, and we also give the agent access to the tools. So we've got these design specification tool, the implementation design. So all those tools we provide it to. But the one thing that we don't do, so here we see here's a rough kind of workflow. So in one of the earlier demos, we used step functions, and we created a state machine. And the thing with the state machine is that that was carefully orchestrated to say this calls this task, then this task, then this task. Here we provide instructions, a set of instructions through a prompt template to the agent where we say, don't return any code if it hasn't compiled successfully. If code doesn't compile successfully, use this tool to fix it. If you get code that comes in, it's not already in Python, create a design specification first. So we provide a set of instructions, but we don't actually hardwire it up in any way. And what we see then when we drop we dropped a Java file, which is a calculator class in. When we go through the CloudWatch logs, we see the logging coming in from the orchestrator agent saying that the provider code's in Java, so now I'm going to use a design tool to go and create a design specification. So first up, I'm going to call this tool the design specification tool. Now I've run that tool and I have a specification. I'm now going to call this tool to go and create the Python code. Now I've got the Python code. I'm now going to pass it to this tool to go and compile it. And in the logs, you see we pass it, it compiles successfully, it runs the test, everything can come back, and then it can go and return the code. And then when we can see the code that we get back when we run it, is you start off with a Java class on one side, and then on the right-hand side, it's converted that to a Python class, following all things like PEP 8 guidelines, fully commented, fully documented. So that's one way that you can start using agentic AI through Strands agents.
All right. So now we're going to see how we can refactor and reforge for maintainability. Essentially, when you have applications that are running on a legacy stack that doesn't meet the IT standards anymore, then it's a good thing to be able to refactor at scale, and that's what we're going to show here. So for this specific example, imagine you're a Java developer and you're being tasked to modernizing mainframe application, which is not an easy task. So AWS Transform actually helps through many of the tasks that are necessary to do such modernization. So in that specific example, we're going to leverage a COBOL application that's running on the mainframe with all the mainframe artifacts. We're going to discuss with AWS Transform to ask for the modernization. AWS Transform will understand the goal and will propose some activities to be able to modernize that application. So we'll start with an analysis agent that we saw before. Then it's going to propose doing decomposition and planning. Essentially, when you deal with a large application, you want to be able to break down the complexity and identify domains which would be modernized one after the other. And so the decomposition agent helps with that purpose. Now, these decomposition agent and planning agent are optional, so they may not be in the full demonstration here. Now, once this decomposition is done, then you move on to doing the refactoring. And that's where all the transformation tasks are being performed. Refactoring is going to refactor, for example, all the COBOL code into Java. It's going to refactor the BMS maps from the mainframe into Angular screen. It's going to refactor the JCLs into scripts. The vSAM data store, which is an index data store on the mainframe, is going to be modernized into a relational database. And then once the refactor is done, if we want to further improve the Java code, we have a new step that's called the reforge agent, which essentially is going to do some further LLM-based operations to refine the code and improve the code so that it becomes even more readable, and do some checks in the meantime so that if the compilation is not successful anymore, then it's going to revert that change. So it's really doing some incremental improvement to the code and make sure the code is still buildable and runnable after each step. So let's see it in action. All right, so we start from the VS Code IDE, where you can see a sample mainframe application. You have COBOL programs in that application. You have BMS maps that describes the screens. You have copybooks that describes the data structure. And you have JCRs for the batch elements, right? So essentially, these are scripts that run on the mainframe that describe all the steps that are necessary to run the batch jobs. Then we get into AWS Transform. We describe the goal, what we want to achieve, and AWS Transform identifies the various agents that needs to be called. We specify where the code is, and it goes through the analysis phase. Analysis phase here is critical because if you're missing any of the dependency, you won't be able to do the full transformation. So it's going to tell you if there are missing programs, missing copybooks, so that the transformation can be successful. Once the analysis phase is done and you've provided all the required inputs, then we can move on to refactoring the code. And that's where, when you refactor, you have to make some decision choices on what the target should look like. For example, you're going to choose the package name for the Java application that's being generated. You're going to choose the target database that you want to use, right? The data access is going to be different depending on the database. You're going to choose the encoding. So you make those decisions, and then once you accept them, then the code gets generated, right? There is a reverse engineering and forward engineering process that's involved, and you can see all the transformation that happened in detail, right? So some of them were successful, some of them were partially done, some of them had issues, right? So you can iterate on that transformation step. Typically, after this step, you would do functional equivalence testing to make sure that everything is running as expected. But for the sake of this demo here, I want to show how the reforge is working, right? So reforge, you would pass it in the generated Java code, and then you would select the specific Java classes that you want to incrementally improve, and then the reforge process will happen, which again is using LLM-based improvements to be able to refactor the code further and provide something that's more maintainable. So this is going through the entire process. All the codes get generated into an S3 bucket, which then you can import back into your IDE, right, inside VS Code here. And you can see it went through the technical decomposition, including entity beans, including the service layer with the business logic, and including the presentation layer with Angular screens, which you can see here on the IDE. So something I want to highlight is the reforge process. So the reforge process that we've introduced with AWS Transform is really designed to enhance refactored Java code. So it can do lots of different types of restructuring of the code. It can add some descriptive comments, understanding what the code is doing. Actually, it can also improve the comments that are inside the code itself. It can optimize the variables usage so that it becomes more readable. It can improve the code flows as well. And in this specific example, what you're seeing here is how it factorizes the code. So essentially, on the left-hand side, you see the generated code straight out of the refactor step. And you can see that the error handling on the left-hand side is quite verbose, right? It's hard to grasp exactly what it's doing and why there are so many methods that are being called. So on the right-hand side, you can see the reforge code, right? Essentially, the LLM has identified that there is repetitive code that can be factorized, so it created the Java methods explicitly for doing the error handling. And then you can see the code is much more streamlined and much more readable on the right-hand side. So this is how you can do mainframe modernization. Now, there are a lot of other steps that are involved, but at least you can see here from this demonstration the core steps that are necessary to do refactor and modernize the mainframe application.
And now finally, once you've modernized an application, you're going to deploy that up into, for example, AWS public cloud. You've got the challenges in terms of how do you operate and how do you troubleshoot any issues that you come across. And this is where agents can become really powerful to help you with this. And one of the tools that we use, make significant use of, is the Kiro CLI. And the reason why, the reason for me why it's so good is that when you're running it from your local workstation, you can provide it with access to your code repositories and to config files, but you can also allow it to assume a role that gives it access to your running AWS resources. And as part of that, there's an example sort of config file. So you can allow it to assume a role which gives it access into an environment, and you can be very explicit in terms of the permissions that you give it. So it may have only a read-only role to a specific set of services in production. It could be more permissive when it comes to things like sandbox or development environments. So trying to bring some of this to life, we've got one example where we have code base open on our workstation, and we deliberately write a bit of code that's going to sleep when it gets executed and is going to cause a timeout. So we can go into Kiro CLI, we can ask it to invoke a curl command to that endpoint. It runs that command, and it gets back an internal server error because there's a timeout. But I can just now go straight in and say, well, can you see anything in CloudWatch logs? And it's in a role, so it goes and describes the log group, find out which is the CloudWatch log group it should be in, and then goes and pulls back the series of CloudWatch log events from there. And it can now see that, I can see the issue, the Lambda function timed out. But now I can just say to it, well, can you look at the code and work out why that may have happened? So now I can go and read the directory that it's in, and it can go and find out and say, well, actually, this is because, in this case, it's a contrived example, but it can say, it can see that this is why it's this line of your code that is causing that timeout. And actually, one of the things that we use more and more in production environments, the dreaded service denied based on an explicit deny in a service control policy. So here I come in and I basically ask it to use a security profile, get the latest findings from Security Hub in US East 1. It goes away and we get an explicit deny exception. And now it's sort of going, well, how do I debug that? But all of our SCPs are defined in config. So I can go and ask it to go and check the file system to find out what could cause that. It goes away, reads through all of the SCPs that have been created, and it actually then pulls out the relevant part because there is a region deny, and SCP is not in the not action list for the US East 1 region. But that's something that could have taken an hour, a couple of hours to try and track down, going through every single SCP to understand why that wasn't working. And to bring it to life even more, these are screenshots from a live production issue. So we run quite a big application that's running on a EKS cluster, and all of a sudden the nodes were all constantly restarting in an auto-scaling group. So again, you go into the CLI and you start asking it, well, can you investigate why these nodes are restarting? We can give it the auto-scaling group name, and because it has access both to all the AWS CLI, but it can run all the kubectl commands, it can go out and it can find that actually the issue was an availability zone balancing issue combined with spot capacity constraints. So it starts getting into quite technical detail, and it can come back and then give you all of these recommendations in terms of how you can resolve it. And if it has the right permissions, you can even allow it to do it itself, or you can then just go and raise a ticket and hand that off.
All right, so these were 7 demonstrations that shows a whole range of modulation tasks that can be improved and accelerated with Agentic AI. So we want to give you some concrete next steps you can take in your legacy modulation journey. On the left-hand side, you'll see a QR code that will take you to AWS Agentic AI solutions. If you want to learn more about the products, feel free to reach out to your AWS teams as well so that we can assist you in better understanding what those capabilities are about. In the middle, you have another QR code that will take you to customer modulation stories, right? Customer stories are a great way to learn about blueprints, usable patterns, so that you can leverage them for your own journey. And on the right-hand side, what's something we recommend to you, which is pretty successful with our customers, is to schedule an experience-based acceleration EBA workshop. Essentially, that's a hands-on workshop where you're going to bring your own legacy modulation assets, and working alongside with us, we're going to show you with real solutions how we can modernize them and show some real outcomes based on your specific applications. So you've seen throughout that presentation that AI agents can really increase the speed and the quality for performing modernization tasks. AWS offers a broad range of capabilities, and you've seen in those demonstrations how you can use AWS Transform, how you can use Queue Developer, how you can use key heroes, trend agents, agent core, etc. So we look forward to seeing how you're going to be able to leverage those capabilities in your own modernization journeys. Feel free to reach out to us if you need any guidance. We're always glad to help. I want to thank again Matt for sharing his insights, his experience, his demonstrations. And I want to thank you all very much for joining us today. And have a great day.